right, so it's 4:30, so we'll go ahead and get started. So I'm Martez Reed. This is a talk on multi-cloud compliance as code with InSpec. So it's actually kind of a follow-on of what Clinton talked about in the last session. So who I am, currently work for Ahead consulting company here in Chicago as a cloud services engineer. Actually started Monday. So I've got, you start and then you go to ChefConf. So a little bit of background on me. I've got 10 years of IT experience and 5 years with somewhat of a security focus. I've been a DevOps engineer, but within the last 5 or so years, I've worked for Department of Energy, Department of Defense in certain areas. So I have that natural focus and attention now to rigid security, if you would say. Ways to find me: LinkedIn, Twitter, GitHub. So now that the preliminaries are out of the way, we'll go ahead and dive into the story. So the first company that we're going to look at is a company called ONESTAT. So they're founded in 1998, and what they do is data analytics for professional sports. So they're the guys that do all those advanced analytics of WAR, wins over replacement, and all those fancy things. They're pretty large at 650 employees, and right now all their services and apps are hosted internally in a VMware vSphere environment, as well as some of the data processing is done in GCP. So company number one, but they have a problem. So the speed of delivery for their application updates is an issue, as well as their interface for providing the customer portal to their partners is antiquated, and they have a desire to migrate to containers. So I'd imagine this kind of sounds like most bigger companies nowadays that are going through that digital transformation. So, of course, they have a problem, so now they need a solution. That solution is a company called Data Farm, which is a newer company founded in 2016 that does data analytics for somewhat of a different industry altogether, but pharmaceuticals. They're a smaller company with 15 employees, and all their services and apps are hosted on AWS. So you can kind of see that sort of natural progression of what we're leading to in terms of you have an older company and a newer company. So older company buys newer company for some of their assets, but primarily the assets are the people to help them fix the problem that they had. So there's a project that the reason why they actually acquired them, because they want to present to their customers and their partners, hey, we're staying with the times, we're going to keep updating. So they're trying to build a customer portal for viewing data for the NBA playoffs leading up to the finals so that they can deliver all these great features and statistics for when the finals is on the main stage. So, of course, that's the goal. And much like most projects, they have a timeline of 8 weeks to do all of these really, really cool things, which I'm sure is uncommon for most of you guys. But the one caveat from their CISO is we have to go fast, but we have to go safe. And so how do we go fast and safe at the same time? I'm sure you guys can figure out what that is. InSpec will help us do that, go fast and go safe at the same time. So their environments. So since it's a recently acquired company, you can imagine that they probably don't have anything in place. So they're building everything from scratch in an 8-week time. And so they're going to leverage Vagrant for local dev. Test environments, they're going to spin them up in AWS. And then prod, they're going to run back in on-prem in their vSphere environment. So they're doing a simple app, so they're going to run Ubuntu for hosting, running Docker, and then they're going to have Nginx, Node, and MariaDB to leverage those. So we got developer's going to run on a laptop, switch to test. We add 2 more nodes for a little bit of redundancy. And then we go to prod to 3 nodes for even more redundancy. And then the data environment in GCP that we're going to leverage for actually connecting to pulling that data out to put into the UI. So gotten through the logistics of the environment and what they're going to do there. So we're going to start stepping in through the potential profiles from a very high level. So for AWS, which is one of the things Clinton talked on in his session, InSpec 2 added support for AWS natively. So we're going to check for things like MFA on the root account, ensure that CloudTrail is enabled, also ensure that the root account doesn't have any access keys for API access. I don't know why anybody would be using root for that, but just want to make sure, as the company as a whole is pretty new to AWS outside of the 15 folks from Data Farm. Then we're going to step into the vSphere environment, ensuring things like NTP are configured on the ESXi host, ensuring lockdown mode is configured as well, and then stepping up to an actual instance level of ensuring that the VMs don't have floppy drives, because who uses floppy drives anymore? Then we're going to step even further up that stack to the Docker host. So one of the things that's actually available out in GitHub is the CIS benchmark for Docker host. So we're stepping through all of these different controls. So really the goal here is to continue to walk through these different ideas and concepts of what we can do from a holistic standpoint. So they also have a Jenkins server in place that they want to do CI/CD and all these newer things. So as an example, just 3 quick controls for like a Jenkins server, ensuring that security is enabled to avoid somebody modifying a config.xml file and saying security, false. Ensuring that anonymous read access is disabled. I think some of these things seem pretty obvious, but we've seen time and time again that sometimes out in the wild that these things don't really translate to being that obvious. And then they also wanted to add in a Vault server for the application for secrets management, for things like Vault, ensuring that audit logging is enabled, ensuring that the storage path is secure since they're leveraging the local file system, as well as TLS. And then we step further and further up the stack into our database server, which is leveraging MariaDB. And then to our application server, just real quick, simple controls that can be implemented to secure the environment. And then finally to our Nginx server. So we've gone through potential controls, and we're going to step through to metrics and how we can pull that data out of InSpec and potentially put it somewhere. So this is real high level, just example of some of the things that InSpec can potentially deliver that data to or display it in. So the one I'm sure pretty much everybody that's ran InSpec is familiar with is the CLI Output. It's really great, but the challenge becomes, how do I scale that across an entire environment, across different aspects? Chef Compliance, which is the standalone component to leverage the metrics into. Then some people might want to use Jenkins for running InSpec and then collecting that data back. And then finally, Chef Automate, if you're potentially running an AWS or Azure and want to leverage that. But what the challenge that ONESTAT found out was that all these tools are great, but there's some challenges with providing a holistic view of the controls that we want. We stepped through probably 8 or 9 different components within the infrastructure that are being profiled by InSpec. And it's tough to look at a single report and say, hey, what's the current status of my entire environment from a compliance or security standpoint, and how do I correlate all these things to one another? So that's where they decided to leverage CLI Output, but utilizing JSON to potentially dump it to something like an Elk or a Splunk to be able to create that rich correlation between all these various aspects of the environment. So now we get to the fun part, is cloud native InSpec. I was actually very tempted to just scrap the whole talk and just talk about this. I think it would have been a little bit cooler. So one of the things I've done is utilize AWS Lambda to run InSpec. And where that's really beneficial is when you want to do those profiling against your AWS accounts to check for things like MFA or password policies. Because, of course, that Lambda function spins up, in a matter of minutes, spins right down. You're not maintaining that infrastructure to utilize that. And then the other aspect is we can also dump that output to an S3 bucket and potentially pick it up with Splunk. And then the other big advantage of this is the scalability across accounts. So for those that have gone to multiple AWS accounts, you can leverage an IAM role in each of those accounts to provide that read-only access for InSpec to run against the account. And then to take it another step further, we could potentially leverage that same sort of mechanism to run InSpec against our EC2 instances by potentially stuffing secrets into AWS Parameter Store, of course encrypting them, and then pull that out at runtime of the Lambda function to execute against the EC2 instance for things like the SSH key, or for Windows, username and password. So pretty simple for AWS, but the challenge becomes ONESTAT is running on-prem in VMware vSphere. So you could simply craft a similar model in terms of how to run it in a serverless fashion by leveraging Vault for the secrets, and then OpenFast for your Lambda-like functions, and then dumping that data to something like Minio, which is, of course, AWS 3 compliant in terms of how it's accessed, to get that same sort of model across both their test as well as their production environment to avoid sort of this constant rework of how they handle things. So in the exact same way, we could use it to hit virtual machines within the environment for those InSpec tests. And the other thing becomes, if you're able to leverage the API, much like with the EC2 API, to describe what that instance is. So the Lambda function or the OpenFast function can pull information about the instance it wants to scan and decide, are you a Windows machine or a Linux machine? So which credentials do I need to get, and how do I need to run against that? So going to the holistic view. So characterized by comprehension of the parts of something as intimately interconnected and explicable only by reference to the whole. What does that mean? That's the definition of holistic, or one of the definitions of holistic. And from a visualization standpoint, that's what it means. To start accommodating for all of the various aspects of the application and avoid the siloing of, well, I own the application, but I don't own the infrastructure. Or I own the database, but I don't own the app. And start really piecing that information together to understand from a security standpoint how we can visualize these things. So this is an example of sort of dashboard. I didn't create anything like Splunk or Elk because really it's just data. But we can, from a very high level, be able to understand, okay, my core services are non-compliant. So that could be my Vault and my Jenkins. And understand, okay, dev is good, test is good, prod is good, but then I can look at my failed controls and see somebody turned off authentication on my Jenkins server. And depending upon the organization, it may not be all that uncommon. But from this, I can see at a very high level the potential for compromise within the tools that are connected to my application. Because I think that's the challenge that's not thought of most often, is all those various pieces within the application delivery mechanism that can potentially compromise your app. And then we can just create another quick dashboard in terms of the test environment. Then we start to look more granularly at our database, the Docker host, the application, the web server, to try and figure out what we're doing from a compliance standpoint there. And then, of course, now everything is green in our production environment because we've had InSpec running in our test environments, our core services, our dev, to understand what we need to do from a security standpoint. And the real benefit of this becomes is that with the situation of ONESTAT and Data Farm, where they've got a very small window in terms of the time they need to complete the application, one of the things most often left off in those crunch scenarios is security. And that's, well, we'll add security in later. But what this allows us to do is easily create those security profiles prior to, and then allow those teams to consume them as they go to avoid that security being left to the last step. And the project outcome was that they were able to get the application built out successfully, and we see that Apparently the Golden State Warriors are playing the Boston Celtics in the finals. Any questions?